If we're all good, all clear, let me introduce Erik Mavrinac.
Thanks, Joe.
Thanks.
How do everybody? Oh, wait, to a clicker. Thanks.
Sorry about that, Erik.
No worries. Alrighty. Am I on the last slide for some reason? I thought that was my last slide.
Sorry, our deck froze.
Oh.
So he's reloading it real quick.
Hey, no worries.
Tell some jokes at people.
Hey, so a duck walks into a bar. Ouch, he says. It's the only joke I know. Come on.
Give us just 1 second.
Sure.
There we go.
Oh, hey, cool. Awesome logo. Anyway, long title, but what it comes down to is we're heading a little bit different direction because of our internal history at Microsoft. I'm from the One Engineering Systems team, been with it since before it was called that, about 8 years now. And I'll show you some of the stuff we've been doing, where we're headed in the short term, and then I'll leave an ellipsis at the end. We can see what happens in the next year, by the next BazelCon, for instance. We're going to do all this. Don't worry, we'll get to it. So we've been doing cloud for quite a while for build. Back in very early 2012, late 2011, when I joined what was then the nascent cloud build team. And some people know about cloud build, some don't. It's internal only. You can't use it, too bad. But we got about 35,000, actually it's more than that now, physical machines, big, beefy, 48-core, 64-core machines, 256 gigs of memory, because I have big builds. We have some half-terabyte enlistments. We have quarter-terabyte enlistments. We have all the way down to a few megs. But one of the things that we were aiming at back then, we started with distribution for MS Build. Anybody who's delved deep into MS Build knows it's kind of difficult, and we got it done. We went from there and added caching. Oh, that's interesting. Somehow we ended up with squares. That's cool. When we started, there were teams. We started in the Bing team, where we were a startup project. Builds there were 10 hours for retail, 6 hours for debug for our first customer. They were one of the biggest. They had some of the worst problems. Mostly had. With distribution only, no caching, we got it down to 16 minutes for debug just by adding more machines once we were able to do that. And we went from 10-hour retail builds to about 1 hour. They still have a lot of single commands that take a long time and a whole machine to run. But you give it more machines, everything gets a lot faster. We followed up with Build Accelerator is this new name. It used to be called Domino, for those who happen to know that. Dual shipped so there's dev cache above and quick build, there's dev cache and build excel. They're different technology stacks, different people, same overall team, just different approaches. And actually, what's interesting is we didn't know the name Bazel back then, because Bazel as a name didn't exist yet, but we started with, on that one of the white papers for Blaze, if it was called that back then, about how to sandbox and how to present nothing but what was specified. And starting with that, and the same concept, we arrive at a build engine that has a different lineage from the stuff at the top. Slowly converging those together takes a while because, well, Quick Build has about 1,600 repos and everything from small to large. Pretty much MS Build only with a bit of the old 30-year-old NT build system. It's now 30 years. Whereas Build Excel started with the hugest code bases, and they're coming towards the center. So we're getting there. Half-terabyte enlistments are an interesting problem just by themselves, and we solved that a couple years ago. Anyway, so this is what we're doing now. What I'm seeing with BazelCon, the talks the last few days, is people converting entirely to the Bazel build language, as well as the Bazel ecosystem, and doing a full conversion away from CMake, all the other engines. It's pretty cool. We've got a lot of this tech, but we never really made it that public. So, just a reminder, since we all know this, but I'll just say it again, what is, especially from the dev point of view, CIs, that's great. We basically solved the CI problem like crazy with 40,000 machines, boom. Well, and 8 years of time and a whole bunch of people, really good people. But from the dev point of view, there's a little bit of a gap. If you're the person doing the refactoring, you're the person upgrading the package that's going to invalidate your whole build graph, it's not so good, right? We use buddy builds. I think I said on the previous slide. We use buddy builds, and I do that a lot when I'm doing a package upgrade. I'll say, change the package ID, maybe fix a few things locally if I can, kick off a buddy build in the cloud. It comes back 10, 15 minutes later saying good to go or you broke, and iterate that way. But if you don't want to break out of your zone, if you want to keep weaving, it depends on your mental model, but I think it was weaving a whole bunch of threads together, and you don't want to break out of flow, et cetera, to go wait for a data center build. We want to be able to hook in at the dev level. But we need more spindles, really, is what it comes down to. More I/O buses, more memory, too. Memory usually isn't the biggest problem, unless you have a real junky laptop. More disks, more spindles, more SSDs, more RAID 0, more stuff that's not on your box and not heating up your lab or your dev machine under your desk. So take stuff and remote it. Get it off your machine. Of course, you could do fully virtual, run it in the cloud only, and that's cool, but we don't have that. We're kind of a big client, fat client company, so we'll run with that. So, challenges. One of the things that irks me because of this down here, I want the dev machine to be primary. If I go and mess with things, because I do it all the time myself, I rearrange code, maybe I didn't want to git commit that yet or anything like that, mess with weird packages, get a pre-release compiler, anything like that. Is the CI system ready to go with, unless it's fully packaged and fully published, CI system's not necessarily ready to go with that. May have some time to catch up. In fact, I have a PR internally that's waiting for an image to get out to the ring of production that those guys are in. Worked for me, doesn't work for them, because this image is still working its way out with the very, very latest nosebleed sort of stuff. But the fun part of this, or the not fun part of this, is what if you have special requirements? What if, say, this image doesn't have what you want? Now you get to go manage your own, you get to arrange for patches, you get to do all that stuff. I find it annoying. It's kind of like a waste of life. Better things to do. Build language problems. So the people at BazelCon have been talking about, hey, we converted to Bazel, its language, its ecosystem, and that's cool. And I don't know what the largest team was as presented so far, but think of it as maybe 100 people. What if you got 200? What if you got 1,000? What if you got 3,000 people? Changing build language, not that easy. What if you have 125,000 build specs? There was once upon a time a team that said, hey, we're going to take 2,000 devs and a month, and we're going to change from this build language to this build language. Any ideas how many, show of hands, how many people, or how many of the specs were actually converted? And that was good. You shouldn't do that. That's a complete waste of, if you want to think of it as business time or time value of money, it's kind of a waste of time. So instead, you leave the 30-year-old language, in this case, the NT build system alone, and you adapt on top of that. So converting everything to Bazel, pretty hard. Plus, you have to retrain everybody. Some of the stuff I heard was we had a seed team. Those guys converted. Then they were the advisors or the Q&A people to answer all the questions that the next tier of 100 people had. It's a good pattern. Again, though, 3,000, I don't know if that scales very well. But I would use Bazel in a startup because I know what happens if you get beyond a handful. Well, it's more than that. The AnyBuild code base is about 32 projects right now. It's about a minute build, it's fine. You get to 100, is that the break point? Is it 1,000? Well, it's definitely 1,000. 200, somewhere in there. It starts to really be bad. You're at 5 minutes. It's go get coffee time instead of you're in the zone. Or even longer, and then you're in the go get lunch time instead of going and getting coffee. So, waste of time. So if we're not going to be converting to a deterministic language like Bazel, we've got to deal with it as it is. But like I said before, we've been working on MS Build and adding distribution and caching to that with a great deal of effort. What we're doing is running predictors. We look at the XML. We say, oh, that's going to have these inputs and those outputs. And if we miss, there's a bunch of mitigation strategies. It's just kind of human time intensive. And I'd rather, if possible, step away from that. And just FYI, in case you didn't know, MS Build is basically its original entry point, or the one if you look on the web, it's called xmake.cs. So it's XML make. Right? So you take make, the file system date times, and you add onto that some in-memory stuff, and you get MS Build. But if you've tried to wrap make in a fully deterministic wrapper with all inputs and outputs predicted, you can guess how that looks. So. And then one of the things is a little bit less prevalent than it used to be, but PDBs, program database files for debugging, often have the path of the machine that it ran on. And I don't know if you've started up a debugger and you got that problem of, oh, d:/ whatever, and you've got some weird path that was from the build machine, but it doesn't match yours and you have to do a bit of patch up. It would be nice not to have to deal with that. Plus, reproducible builds, it's a website, it's underway, people are headed that way. A lot of tools don't support it yet, or if they do, they're off by default, so you kind of have to remember to go turn on reproducible outputs from the same inputs. And I've alluded to this already. We solved the CI problem really, really well with tons of hardware and a lot of effort. That's great. Do a lot of buddy builds, but again, I don't want to break out of zone. I don't want to git commit, push, run a buddy build, wait for it. Waiting for prep time, pull the latest packages that maybe I upgraded, or wait for it to wander the dependency graph building because I touched windows.h or some equivalent in my code base. So what are we doing? This is a prototype, although it did ship internally. And it's based on Bazel remote execution. So we're starting with that protocol and then varying, and then we'll bring it back. That's part of the plan, at least as of this moment. We wrap the existing build engine. So we take msbuild.exe and just run it. There's another NT build system from 30 years ago has another tool called build.exe that's still around. We wrap that too. I've wrapped gulp and I've offloaded Mocha tests onto different machines. Makes my laptop a lot happier not to have to do all that stuff. We have a CAS. We use the same CAS protocol. In fact, that's the one thing we do most of is byte stream and content addressable store. We pretty much use near 100%, except we're not doing directory Merkle trees yet. The other thing is, like I said, I don't want to trying to deal with your image, your tool. Oh my gosh, I'm behind because tomorrow that'll ship and you're stuck today and you can't get your CI build through. The dev machine's the master. All of your files just get uploaded as is. If you have a special patch, if you just installed some new tool that is an admin installed tool like Visual Studio, we just get what you just deployed. It just goes in the CAS. It's just a file and we just run it. And that's using some new virtualization tech I'll be talking about a little later. And then, importantly, because I don't have purely hermetic build nodes, whatever a node is in this case, could be a process, could be a higher level construct. I try to predict, but if I miss, I don't want to be broken. So we have a new contract that's an extension of the RE protocol that we'll be delivering back eventually that reaches back. The server can ask the client, what's this directory? You didn't tell me about that. Wasn't predicted. Hey, what's this file's hash? Oh, good, I've got it in the CAS. Let's go use it. Oh, wait, I don't have that. Can you just give it to me live now? So unlike the Bazel RE protocol is a bit more of a batch protocol. Here's some work. Let me get a monitoring stream back. Instead, any build is, you need to be here live because I need to ask you questions. Hopefully not, because doing so is lower performance. But it doesn't break. It just slows down. And then you get some telemetry and you follow up and say, oh, yeah, we've got a new compiler that does some new thing. Let's tweak the predictor, test it out, get a regression test in place and launch it in a few minutes, and then you've got better builds the next time. But you don't break. High level, it's kind of as you'd expect. Oh, there's animation there, it didn't run, okay. My dev desktop contacts the cloud, reserves agents. If I can take a piece of work that's interesting, in this case, we're just doing the cl.exe compiler right now, which is Microsoft C++ compiler with full support. I'll show you a demo in a little bit that has a different result. But from my dev desktop, it contacts, in our case, just over the mountains from us in eastern Washington. We have a data center there, and that's the lowest latency that we can get, so just contacts that and does it. Down here, it might be our Bay Area data center that we deploy to. So we have one repo that we're working with, one team in the OneDrive team. They have a repo if you run Windows and you've got the OneDrive icon down there, it's those guys. They have a lot of C++. Since we're doing the compiler first, we figure we need somebody with plenty of C++. And they're about 60% of their code, or their code base is C++ compilation. So they, by default, have fairly beefy machines, 612s, 6 real cores, 64 gigs of memory, et cetera. We'll get to that in a second. About 40% savings, just with CL remoting. We'll be adding more commands, much more remoting in the next couple months. This is mostly hot off the presses, although I did present similar numbers a couple of months ago. It's a little bit better than Build Meetup London. Pixelation. On laptops, my laptop runs so cool, I can read email at the same time. Because those big, We're remoting stuff that's big typically. And this team has a repo or a portion of their build that runs 206 CPP files at once in one big multi-threaded compilation. I'd rather that go to Eastern Washington than be on my laptop. So some details. This is like when you hear a radio commercial and they have to go into that fast speak at the end. But basically, it's kind of what you'd expect. VCX projects, there's 300 out of 500 that these guys have in their repo. It's the first repo we're doing, but there's much more coming up internally, and then we'll start to look at external stuff. I'm going to get the bugs out first. Details on Azure. We're just doing the compiler just like Goma. Goma had success with that. We thought it was a good place to start. And we boost the parallelism settings for MS Build, but we also leave single CPP compilations locally. So we have a predictor that says, oh, that looks like enough work. It should be remotable. Because there is a cost to remoting. You have to upload files, check the CAS, run the command, do all this stuff. So why waste the time for something small? Oh, video. There's supposed to be a video there. Sorry about that. Let's do the first video, if you could, please. So another result. This was from last week. This is hot off the presses. In fact, I supplied videos rather late in the game here. On the left is our agent. On the right is Bazel. This is a loopback case. And the first thing we had running is taking a while for some reason, partly because it's sending a link command and we're reaching back across the local socket, but it still takes a while to get all the files to run link. So again, we didn't break, but we just ran slower. Come on. It is remote. It's right there. Anyway. So the net result is we have Bazel as well. We have that hosted at the edge of our agent. So we have our own custom protocol. We have the rest of remote execution running there, and it works. Oh, we're looping around, so. Okay, switching slides. So yes, I had an intern. He did a great job. Will, he's not here right now. Maybe he's watching. So we have our own custom with that two-way socket protocol that lets us reach back and get rid of problems with hermeticity. We now have Bazel client, or the full Bazel RE protocol, including not us. Next question, you might go, well, Goma was a success, but maybe we want to run this in the cloud. Maybe you need Goma. So we might do that. We're talking about it. But there's one piece missing, and this alludes to one of those early slides I had, is that when we first ran Bazel, we had to put in a bunch of hacks to say, if you can't find the path, just go locally. In other words, on the loopback machine, the command we get is like c:/program files, Visual Studio 2019, blah, 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 cl.exe. Problem is our agent didn't have that installed. We have nothing on our agents at all, except for the OS and our software. So one of the problems we ran into is I don't want to go install stuff. I don't want to be chasing that horrifying non-dream of having to keep up with every nuanced version of every Visual Studio and every tool and everything else. I just don't want to be bothered. So we rewired it. We made an adapter, and that's the next video, if you could, please. So this is an homage to last year's demo, which I found amazingly great, 600 simultaneous Bazel remote execution agents. And we upped it a little bit. I was aiming for 700, didn't quite get there. There's still bugs. But up at the top, you can see it's running remotely. We'll let it run through. I drastically sped it up because we could stand here for 5 minutes and let it run. But the agents in this case were not loopback. They were running in Azure in Eastern Washington, same place where we do our remoting. And then I had to shut it down quickly because the guys are like, whoa, whoa, you're spending all this money on VMs. I'm like, yeah, demo. So, oh, we're looping. OK, that's cool. Switching back to slide. So how are we doing it? What are we doing? Internals, let's see. So this is how it works. So let's say Visual Studio. I actually don't have that integration, but it's coming real soon. We're talking to them. It's going to run MS Build. We're going to wrap it with an AnyBuild sandbox. And we're going to let MS Build do whatever it wants. So again, I don't want to second guess MS Build. I've spent 8 years doing that. It's OK. But sometimes, like MS Build has its own stuff, just like CMake, where it says, oh, well, these files are up to date. We're not going to run this command. We're not going to run this half of the build graph. I'm going to let it do whatever it wants to do. But when it goes to run a compiler, it's like, oh, that's interesting. And I say, yes, I want to do that. So I replace it. MS Build still has a create process called pending. We stick a different process in there. We stick ours in there. And this guy then loops back up to the enabled execution environment. We register an agent out in Azure, and we run the compiler out there. All the inputs are obviously preloaded, but there's a set of steps for that, which is fine. Upload stuff to the CAS. We give a file system layout to the virtual file system manager up there and say, I've got all the, like I could have my repo on X, my X drive. I could have the tools on C, or maybe I like to put Visual Studio on D for some reason. No problem, got it covered. We virtualize all the drive letters, we virtualize all the paths, and everything running up there thinks it's running on your client, except it's a different kernel and a different state, typically. So when that completes, bring the outputs back and write them back to your disk, just like you would expect. Your machine is still the master. You still get back stuff with your paths in it if it happens to write an output path in there. And then we let go of the agent for the next build, whoever that is, even including myself. We can do the same with test tools. We don't have prediction for this yet, but we're working on that. It's on our list, not far away. And then you do the same thing, replace it, get an agent. Oh, skipped. But we don't want to remote robocopy. What's the point? You'll copy all the files up into the CAS, you'll copy them to another directory, and then download them all back. It's kind of lame. So obviously, we don't want to do that sort of thing. OK, the drivers we're using. So anybody who's familiar with GVFS should know about or have an idea of how it works. If you do, it's projected FSLib or ProjFS. ProjFS, so in Windows land, we don't have a Fuse driver. We've tried, I tried with a small team a few years ago, dodgy, just because there's a lot of compatibility APIs down in the file system that are hard to support with pure virtualization. So the Windows team came up with GVFS. It's based on an older system called Ghost. You need a real drive, and you mount a directory under the driver. You create a directory and call that a virtualization root. And inside of there, then you can place what Ghost was. You'd have to create all the directories, lay down. For every file, you put a placeholder saying, if you want to read me, pause, let me go get the file from somewhere else. That's pretty easy, and that's how GVFS works. You virtualize the Git file system locally, et cetera. But what GVFS was designed, and what ProjFS was designed to do for GVFS, is to avoid writing the whole disk with a bunch of placeholders, because the Windows code base is 4 million files. It takes a while. Even on an SSD, it takes a while to write all that stuff out. So what they came up with then is, well, why not ghost the, or virtualize the directories themselves? So you create the root, you say virtualize there, and it's just sitting empty. It's when somebody CDs into it and does a directory, tries to run something on a subpath, it then starts rendering directories, contents, files, et cetera, just like it would have before. The other thing that we're using is brand new. This shipped in 1903, which is now 6 months ago. It's in 1909 as well. But there's a new driver that lets us remap paths across drive letters, et cetera, down in the kernel, so we don't have to try to hook in from user mode and get things done. So put those two together, build Excel sandboxing, which is using detours, and we've been using that for years and years and years. So that's pretty well baked. Gets us what we're doing. Azure. So we're a data center company now, among other things. Office, Windows, no. Oh, yeah, data center. It takes about a half hour to deploy a full cluster. It takes 2 minutes to upgrade it with a new version. Once it's out there, it auto-scales using VM scale sets. We're using kind of all the standard stuff, security, blob storage for some CAS work, Redis for our cache, which I'll talk about in a second, Cosmos DB for tracking machines and some stats. There's also some telemetry we're not talking about that's internal, but we're aiming to get that to be a public version of everything. So how much of RE are we using for our protocol? All of ByteStream, most of CAS. Like I said, we're not doing directory Merkle trees yet. It's been in my backlog for 6 months. And I think it's going to have a huge perf win, so I keep putting it off. Capabilities, we just don't do that. We just have const. And const long size of buffer equals 2 megs, whatever. We'll get that in there. Action cache, we're doing it a different way, and I'll cover that in a second. Execution, we're doing entirely differently, but I've been asked to try to get the two-way protocol added back into RE, and we'll get there eventually. Not quite ready for that yet. So this is the two-way protocol. One thing that's different from the Bazel RE protocol is that I try to maintain fidelity of standard out and standard error. If you've looked at Bazel RE, you get standard out as a block of text and standard error as a block of text, and it's hard to tell from that, how they're supposed to be interleaved. But because I'm live streaming on a live call from the client, we're streaming individual standard out and standard error as they happen. So your build looks like it's progressing completely normally, even though the standard out messages are coming from far away and across the internet to you. Like I said, the agent can reach back, and I'll illustrate how trying to include a file that we didn't predict works in just a second. And then we're not doing this yet, we don't actually have a good UX, or any UX really. We silently just speed you up. But what we can do is say, hey, that was great, but our agent had to reach back for this piece of data. Can you just add some metadata for it? If you know VCX prods and you know about CL include, add it in, boom. We could even obviously propose that as a PR if we wanted to go that far. Not there yet. And here's some details on what we were doing to get the tools to automatically upload. So I don't want to chase. I just want to let the remote file system virtualize everything. So Bazel AnyBuild adapter runs on the client side. And so when you tell Bazel with RE to go and say, do 700 things simultaneously, we can take 700 socket connections to that process. That process then owns the AnyBuild side of things, get agents, potentially a lot of agents, like in the case we had before. Deals with the pool, but it also takes the command that Bazel sent, because again, it was sending us C program files, blah, 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 and does the standard AnyBuild thing of saying, let me hash all that and just send it up as entries, and then let me virtualize it on the agent, just as though it was local. So it's your EXEs. If you just patched, that's fine. It's just a different CAS entry to me. The only thing we can't do, or I won't say can't, but the only thing we're not planning to do is to remote the registry. So if your tool needs to look for stuff, too bad. So it needs to be Xcopy deployable. Most stuff is like that, but some people like to go to the registry for some reason. No tool installs, happy making. So missing header prediction, everybody's encountered this. And I called it bar.h in this case, that's fine. We also look for hints in the VCX proj, I alluded to that. So if we're running CL in a directory, we look for a VCX proj there and parse that to find CL includes. So as you might expect, this time let's do it in VS Code. I like VS Code, it's really good. Run our AnyBuild sandbox and run msbuild. We have our local disk. It's already connected to an agent. We start running up there. So here's what we're going to run. Cut the path short so we don't have to talk to it all day. We're going to run foo.cpp. We're running in c/repo/foo. But the binary is over in another directory. So the loader, Windows loader, is going to do its usual thing. Hey, file system, tell me what's at c:\\. We got that predicted, at least in our current code. As long as it's predicted, it's pretty quick. The callback comes and is resolved very, very quickly. So as you can see, we have a root dir, and then the 0 is just because we can have several commands running simultaneously. Cleanup overlaps the next execution. So 0. C, just the drive letter. We can have B through Z. A turns out to be problematic for ancient reasons. But then it says, hey, I want to do C/bin/CL. So it goes and says, what's in C? And we say, well, there's bin and repo eventually. We present it with the full view at that moment. But it says, cool, I want bin. What's in bin? And we say, well, there's CL, C1XX, C2X. That's, there's usually like several megs of stuff there. And it says, cool, I want you to run that. Loader loads it and starts running it. From our point of view, it's a callback, and we feed a stream back to, for in this case, cl.exe and its DLLs. Each one gets a callback. We stream back the contents out of the CAS. So then, once it's up and running, wants to load foo.cpp. Well, that's easy. We already have C rendered, so we can skip right past that. But we go to a different subdir repo. That's fine. We had that predicted. And then it goes into the foo subdir, and it finds foo.cpp and streams it back to the compiler. It's released, and it's done with I/O, and it starts processing foo.cpp and generating outputs into the real file system. Let's do the header, problematic header. So it goes back to C again. I need C, or actually the full path would be C:/repo/bar/bar.h, right? We already have the C and repo directories rendered from our previous commands, but we don't have bar, and we don't have it in the predictions. Now we're kind of stuck. What are we going to do? We could break, or say, hey, client, tell me about that. So client says, I've got bar.h in there. And we say, cool, here you go. Enjoy. It says, well, I want to open bar.h, callback, but now we're stuck. We don't have bar.h. So we ask the client, give me the hash of that. It could be in the CAS, could be not. Typically, for this sort of case, the second person to run doesn't have to go get the file, which is, let's say we have to do that. So live streaming over the live socket. Need a file, we just get it. The CAS, so we have a lot of tech. After 8 years and, well, in the build area, I don't know, where are we at, 30, 40, sometimes 50 people, sometimes less. BuildXL, which is open source since earlier this year, has a ton of stuff in it that's interesting from Mac drivers and other things. But we have a data center capable peer-to-peer cache, and it's being refactored for our case, particularly right now, which then opens up some other possibilities for other operating systems. It's all net core, so it's uses standard services like Redis and just works. We can get it, it's already running on Mac, it's running on Windows. We could extend that to Linux very easily once we get going on Linux. The CAS itself uses gRPC. They switched to that 6 months ago from an internal format called Bond. It's all the same idea. Uses Redis, like I said, and then LLS is what its name is for. I think it's using RocksDB. They've gone through 4 or 5 DBs because they don't scale very well. So they keep changing stuff up. It's just fine. The client has a CAS. We only put stuff in there that's deterministic. So what's the point of storing a PDB file when the next build is just going to rebuild the PDB again? When we get a local cache going, that'll change a little bit. But as it stands now, when we're downloading stuff, if the flags are turned on for determinism, we put stuff in the client CAS. Otherwise, we just don't. Just put it on the disk. And the other thing is, so the CAS, as it's tuned for cloud build, BuildXL on cloud build, quick build as well, as we get moving through that, it's tuned for never fail, or fail as little as possible. So it has this paranoia about, I need to get every copy of everything I need onto the drive before I let you continue. We had them retune that for us, because really, because we can reach back to the client, we have all sorts of options. We can be optimistic. We can say, yeah, tell me what you believe you have somewhere and start the downloads, but I'm going to go back to the client and let it call back again with the command to run, so we get more overlap. And it works really well. We have maybe once a day we miss one of those files, so it's not bad. So the roadmap. This is tactical. This is 6 months. We're still discussing what to even do with this. There's a bunch of stuff we can do. And there's an entire dimension I'm not even speaking to here. So assume this is Windows. I'm not talking about Mac or Linux at this point, but it's interesting. We're working on a 2-phase lookup build cache, and the 2-phase protocol we'll bring back to RE at some point. 2-phase has had some other talks done on it, essentially because if you don't have hermeticity, you have to deal with that. Quick build does it one way, which is to break you, saying, you touch this, you're not allowed to do that. You have to add some annotations. In BuildXL, they have 2-phase lookup, which is make your best guess, tell me what your best guess was, I'll hash your best guess. Run out with that hash to the data center and say what you got, and it'll say, oh, I've got 3 things that ran previously, or 3,000, which causes problems. But from your hash, I got 3 things, but the file system was laid out with these hashes in these positions. So if your file system looks like that, do the next step and go get the outputs from that build, or from that build target. So we're working on adding that in, and then we'll bring it back to Bazel, or to the remote execution protocol. Client-side virtualization, that's something we have tried and failed, but ProjectFS is pretty cool, and I'm porting it to NetCore. It's the PR that's stuck right now, because it needs bleeding-edge tech. With ProjectFS on the client, though, we can try some new things. Some of it would be, during the build, don't download stuff you're not about to use on the client, which typically the PDBs are not used, they just need to be downloaded. And we can go a bit further and say, kick off an asynchronous process to answer the callbacks after we're done exiting any build.exe, and let the thing answer placeholders. So we could place down placeholders for every output, or the outputs that we're pretty sure will never be used. We can use stats for that and get a loop going. It's experiments, though. Don't know how it's going to turn out. More command remoting, I alluded to this. The team we're working with now uses a lot of classic Microsoft C++ stuff, so they're doing RPC with middle, and that turns out to be a fairly beefy process. We'll get that off their boxes. Link is mostly copying from here to here with a little bit of computation, unless you're doing LTCG. So LTCG link will be our main concern, and we might turn off just plain old debug link, because it's mostly just I/O. Lib, same thing. Clang, I'm talking with the team that's using Clang, and so we'll have to add support for that. C# is an interesting one. The shared compiler causes problems. It's very performant, but if your machine is overloaded, how do I fork some of that off to the cloud while still letting shared compilation do that really fast thing that it does? So we're working on that too. Unit tests, that's the other thing, is People in BuildXL are like, oh, it'd be so great if these beefy unit test suites didn't run on my poor dev box. I'm like, let's fix that. So we'll do that too. Visual Studio integration, I just don't have it right now. It's coming real soon. Internal customers, I have some game repos. I've got the Visual Studio team, maybe. We'll see how that goes. And we're going to go open source. So what I'm talking about here isn't theoretical and not available. Well, it is right now. Give me a few months, though, we'll see what happens. Got a lot of compliance and security stuff to get through, and some internalisms that would be better not to show you. We'll get rid of that and ship it. Like I said, we'll be bringing back stuff to RE. So we got two-phase cache lookup. We've got the two-way protocol extension. They just can be added as optionals, and we'll see how that goes. I do have to make my stuff look more like actual RE instead of let's hack it and get it working. So there's some work to do there yet. More build engines. So another team that we have is moving away from MS Build and into CMake because they need, they're moving to, actually they need all three OSs. So they like CMake. They're not moving to Bazel. Too bad. Maybe we'll talk to them about that. But given they're halfway through their conversion, by the time I get to them next week, they'll probably be all the way over to CMake, and I'll add support for wrapping that. It's like a 5-minute single PR to get that done. And then we can go back to BuildXL. We can go back to Quick Build and get our existing customers who have huge repos, like 3,000 targets, 10,000 targets, these guys, targets being proj files. We can get those guys running with remote execution. And again, if you're getting dev cache from an old data center build, that's great. If you're changing a leaf, that's great. But if you're the guy doing the refactoring, why should your life be so bad? Let's make it better. And GOMA, that's an interesting conversation we're having. And I don't know if we'll have to write an adapter, so we auto-upload the tools. So links, these will be in the slides as they get sent out. Any build is out there as a repo, but it doesn't have code. It's mostly my marketing materials that talk about what you would have if you wait for another n commits. I don't know what it'll be. BuildXL has been an open source since early this year. We've had previous talks about some of the tech in there, including Mac sandboxing, Windows sandboxing, et cetera. For those who don't know about Cloud Build, we have a white paper that was a few years ago. All the numbers are very small. All the numbers are now much, much, much bigger. But it was mostly the same system as it was then, except with some new caching, a few other things. We should probably update that white paper eventually. MS Build. VFS for Git is the rename of GVFS. There's a repo for that, but not a caching server. I was going and looking for that the other day, and they don't have one up there. And if you want to know about the depths of ProjFS Managed API wraps an unmanaged DLL that's in Windows starting with RS1 3 years ago, 1607, I think that was. So they now have a public API that's what's used by GVFS, and if you're in C#, they got a managed C++ wrapper that will, by tomorrow, be moved over to Netcore 3.1, or dual target Net 472, Netcore 3.1. And that's it. Cool. Any questions? Oh, sorry, please. Thank you.
Thanks, Erik. I appreciate your talk. As you guys know already, the questions.
Yeah, line it up.
Thanks so much.
Please.
Hi there. So my name's Ed Schouten. I'm the author of BuildBarn. I actually have two questions. So with regards to the two-way protocol, what happens if there's a missing dependency on a file that hasn't been built yet? Would that mean that the build action sort of gets stalled at that point?
That's a great question. We are going to break. This is not we're not doing speculation, we're not holding it. We're assuming MS Build knows what it's doing. So if you have a bad build graph on your client, you got a bad build graph on the server, it's going to break. It'll have a file not found just like it would have before.
Yeah, I mean, it also makes sense, right? Otherwise, you'd have to pass the build action, and then you get really low utilization rate on your build.
And remote execution has a speculation protocol where you upload the graph, and it can run ahead, and as outputs become available, it can quickly start getting the next things going on a frontier. We don't have that for this, and I don't know, it's possible. As we develop or implement more of the RE protocol, and if that becomes a standard, we'll take a look. But a lot of what I'm doing here is just reacting to what MS Build is doing. I let it do all of its file system checks. I don't want to second guess it, because I spent a lot of time doing that in the past. Let it run, and if you're fully up to date, we won't even be called, because even if it runs CL, and if it's too small, like a single CPP, we'll just say, go, we don't want you. As soon as it builds something big, we'll take a look. So.
Okay, so the second question I had was actually related to a pull request that you folks sent to the remote APIs repository, namely you folks added a new hashing algorithm.
VSO 0, yeah.
VSO, yeah. I was wondering about, so like for the audience, so VSO is basically sort of like a recursively defined hashing algorithm where you first...
Not recursive as paging hash.
Yeah.
So every 2 megs, you start a different thread, task,
Yeah.
whatever, and let it, so for large files, you get run across 2 megs of input simultaneously across the file. And then you hash the hashes. And there's
Yeah.
a seed that's funny just because of who wrote it. So.
Yeah, so one of the things I was wondering about that, do you folks also use that for like doing in-file deduplication, so that you actually store that at the
Wow,
right
what a
level?
great question, yes. So this, I don't even know how public this is, but there is a system for that. A lot of stuff, the prefix is different, but the backend is the same, like, you know, for the GUID case. The GUIDs and the timestamps are in the header in the first few K or even first meg, whatever, and then you quickly generate the same code layout. So yeah, why should you send back and forth the latter half of a file like that? Windows has a system for that. I'm trying to remember the name of it, the feature name, but it's Delta Download or something like that. It exists within Windows, and then we have an internal protocol that does much the same thing. Public, be a good thing to talk about next year, let's say. See how that goes.
Thanks.
Let me do upward real quick. Hi.
Hey, Zach Chappell, we're for Ultimate Software. So we have a really large .NET app, but it's not .NET Core. We have builds that take like 6 hours plus, which is kind of terrifying.
Let me fix that.
Yeah. So one of the things is we're looking at moving to Bazel just to kind of speed that up a little bit, but the .NET rules are kind of neglected a little bit right now.
Are we involved? I have to ask that because I'm not.
That's
And
what I want to know.
don't
Are you going to get
we're
involved
a large
with .NET
company,
rules?
and for all I know, left hand, right hand. The left hand could be doing all sorts of stuff. But
Right, so that'd be something that I think would be interesting to see if some of the stuff that you're doing on this, as well as the .NET rules, would kind of get some love like TypeScript does.
I'll take that back as a please, because I need to answer the question myself. I'm not in the Bazel, like I don't use Bazel client. We have all our own build engines, but I wanted to get RE. This opens up interesting possibilities. And on that case, I'll find the people who know, or I'll find nobody, which will be an interesting statement too.
Okay, thank you.
So, thanks. Down here.
David at National Instruments. You say you hook any build proc basically, or all the subprocesses,
Yep.
yet you still only remote individual specific commands?
Correct, yes. I do have a mode where you can invert and say remote everything, but that tends to break quickly because of registry, typically.
Okay. And that goes to my next point, is Incredible XGE is kind of the same thing, except it
Oh, you
also
noticed that, huh?
remotes the registry.
Yeah, they've had more time to write code.
Okay.
I could remote the
did-
registry, I just don't want to, anyway.
Did you not use that because of payment or because of,
It's a great question. Really, we've got all the tech. And when we we were here or in New York for BazelCon last year, and the 600 simultaneous thing demo, I was like, yeah, but we can do that. We've got all the tech. Really, I'm assembling pieces here and spending a lot of time in the middle and prediction and stuff like that. But you're right, it looks very similar to something else, doesn't it?
the other reason that I think you could write your own here is because of the CAS, which I don't think Incredible XGE has.
I had not from their docs thought that they did, but
Right.
I've never installed it. So.
However, Electric Cloud has that sort of
Sure.
CAS and sharing among the build farm.
I've got 3 devs, 5 devs. How big is the cache team? 5.
Sure.
I've got 5 people who spend all their time worrying about 40,000 plus machines, 35,000 machines, and full scale across all those, and now my case too. So
Right. Electric Cloud does also have some sort of the speculation, but not really speculation. It's rather like they detect failures and then undo and redo
and yeah.
to reorder things.
That's
as
why
if
I
they
wanted
had
to let the
happened
build
through.
engine have its own graph. I don't want to second guess the graph. I'm really kind of tired of that. So I'll let it run and do what it wants to, and I'll just say, that looks juicy, let's remote that.
Final
We
thing.
could change it, but that's what we're doing now.
Final thing. When do you expect Linux and Mac to come?
No idea. It's a conversation not even started yet. So, but it's an interesting idea, isn't it? Kind of cool. We have sandboxing tech for Mac for Build Excel. Linux, I hear, is not that hard. Not a Linux guy, old Windows guy. We'll see. Let's talk next BazelCon, see how that goes.
Thank you.
All right, my name's Adrian Oni from VMware. So
Adrian.
you noted that you have a system where you can do partial matches, where basically you have some degree of prediction of what you think you may need on the other side, and then later you may end up saying, I'm going to return you multiple records, and those multiple records will help you figure out which of the things on your file system you.
You're talking about two-phase cache.
Yeah, the
okay.
two-phase cache.
Gotcha.
How does this interact with, say, searching for headers when you're doing a compilation? and the header is missing in one directory, and
yeah.
you find it in the next one.
Smart
Do
guy,
you
okay.
actually put in the records the fact that
We
there's
do.
stuff missing?
We saw the directory enumeration order. We store that in the order. So when it's played back, when you're given it's called a path set. And this is all in the build Excel public code base. Path set comes back, and part of the thing that the path set examiner, whatever the class name is, what it has to do is say, replay in the same order. And we did store in there the fact that first you went there and it wasn't there, then you went there and it wasn't there, and then you went here and it was. Because if you stick your header there suddenly in the first place, we want it to be a different hit. So good thinking, and yes, that's in there.
Hi, I'm Kalyan from NVIDIA. My question is, are there any plans on your roadmap to integrate your remote execution with your CI? So your CI builds are much faster?
Yes, actually, I didn't talk to that. How do I put it? I was alluding to this. We've spent a lot of time on CI and making CI better, and a bit less, let's say, on the inner loop case for just the devs. So my first personal focus is let's make the dev teams I'm working with, eventually outside, make that faster. But yes, you're right. You could take the exact same thing, so Azure DevOps pipelines, if you're using that, or you can conceptually say anything that's going to run a build. Provision a pool, hook up the config, hook up the authentication, and go, and you'd speed up your CIs, including in ADO. That would happen. We're not running that yet, even as an experiment, but it's way down our backlog. I just didn't feel like copying all that into the slides. My backlog goes like 80 slides, so.
But it
ideas,
seems
right?
interesting because probably the same problem on the CI in terms of maintaining the configurations required.
Yes,
So kind of maybe you can solve in a similar way or
fully agree.
make it
And
more
I just-
intelligent, like you only go to those missions which have the configs.
January's coming, and maybe I'll get another person. They can go try it. We'll get that wired up. But you're right. You're absolutely right. Just not at this moment.
Oh, okay, thanks.
Talk to me next BazelCon. Let's see what happened.
Sure.
Anybody else? Nobody up there? Nobody down here? All right. Any other questions randomly? Cool. Thank you, everybody. Appreciate it.
Thanks, Eric. I appreciate it.
Take care. Thanks a lot, sir.
Okay.